All right, this is the second video within our trigonometry unit. It is covering trigonometric ratios. And this new concept allows us to relate the sides and angles of a right triangle. So instead of just looking at the sides with Pythagorean theorem, now we get to add in the angles. This is the introduction of trigonometric ratios. The basic trigonometric ratios that we are going to see is sine, abbreviated as sin. It is not sin. It is sine. So whenever you say it, say sine, not sin. We have cosine, that's COS shortened. And then we have tangent, shortened as TAN. Sometimes people say tan. I do that. We should say tangent, but if you hear me say tan, it's short for tangent. Okay, how do we build these trigonometric ratios? Well, the ratios are kind of just taking sides, which we'll label as opposite, adjacent, and hypotenuse, and put them as a ratio or a fraction, okay? And inside our trig ratios, we're going to put in angles. In this case, we're using A. So how do we do this? It all comes from labeling our right triangle. How do we label our right triangle correctly? It's based on the angle that we're looking at. Okay, so let's take a look at this triangle right here. It's a right triangle because we have a 90 degrees or a right angle. How do we label one side opposite, adjacent, and hypotenuse? Well, all depends on the angle that we're referring to. So we're not ever going to refer to the 90-degree angle. That is always going to be stable. That is required for us to have a right triangle. We're either going to look at this angle right here or this angle right here. So this angle that's created or this one. How do we tell? Well, this one has a little indicator right here. So we're going to be going off of what we call angle A. So right here, this is angle A. You can write it as angle A like this, or what IB writes, A as A with a little hat to indicate that is the angle. So we're going to go with that one. So this angle that we're looking at, we're going to call angle A. Okay? That is the angle we're referring to. So from there, now we can label our right triangle. The hypotenuse is never going to change. It is always going to be opposite to the 90 degrees. So the same thing that we did with Pythagorean theorem is going to be here. The hypotenuse is literally opposite to the 90 degrees. It's a side not touching it. So whenever we're dealing with it, hypotenuse not touching that 90-degree angle. Okay? So that's opposite. So hypotenuse is the easiest one to identify. Then we have to take a look at the legs. How are we going to write, how are we going to label opposite and adjacent? Easy. Go off of the angle. Here's the angle right here. What side is opposite to it? Literally the side not touching it. This side is opposite to it. So we're going to label that opposite. Adjacent just means next to. So if you ever see adjacent, it means next to. Well, which leg is literally next to the angle? The one touching it. So adjacent means next to. What leg is next to or adjacent to the angle that we're looking at? And then the other side is opposite. So right here. Again, the hypotenuse is literally the side opposite to the 90 degrees. Okay. We have trig ratios that deal with the sides that we just labeled. So let's take a look at them. Sine of angle A, again, this is angle A right here, that angle that is created at point A. So this right here is the angle. We read it as sine. So we read this part as sine of angle A. So sine of angle A is equal to the ratio or the fraction where we take the opposite side. So literally this side right here over the hypotenuse. So if we take those two side lengths, put the opposite over hypotenuse, is it equal to the sine of that angle? We'll dive more into it when we get there. We're just worried about constructing trig ratios right now. So that's sine. The next one is cosine. So when you see COS, parentheses, the angle, you just say cosine of angle A. It is equal to adjacent over hypotenuse. So instead of doing the opposite like we did for sine, now we deal with adjacent. So we're taking this side over the hypotenuse. The last one, tangent of angle A, tan of angle A, is equal to the opposite side, opposite, over the adjacent. So really that one's just dealing with the legs. What we're going to be doing is constructing the trig ratios. So they're going to give us a triangle, and we're going to construct the proper form for these trig ratios. Let's dive in and look at an example. The first one asks us to find the tangent of A, angle A. So what is that going to look like? Well, we're looking for tan of angle A. Well, if we look up here, tan of angle A is this one. We're looking for the opposite and the adjacent. So let's go over here. I'm looking for opposite over adjacent. So we need a label. The first thing we need to do is label our triangle. Okay, our right triangle. Find the opposite and adjacent and just make the fraction. That's all we're doing when we're constructing. We're practicing constructing this trig ratio. So looking at this right triangle, first step what I'm going to do is label my hypotenuse. So here is my 90 degrees of my right angle, side opposite to it right here. This is the hypotenuse. So I'm going to literally write it as HYP. I'm going to actually do it in red just to emphasize for you guys. So this side, 13, is my hypotenuse. Okay. Now, based on the angle I'm going to look for, the legs are either going to be opposite or adjacent. What angle am I going off of? A, angle A. So you can see right here, I'm looking at angle A, which means this is my angle right here at point A. So this is my angle. Based on this information, what side is opposite and which side is adjacent is what I'm focusing on. The side opposite to it literally is 12. It is not touching it. So this is opposite. The side that is adjacent or next to, literally the one that's touching it, is this one right here. This is the adjacent one. And there we go. I have labeled my triangle. Now I just need to construct the trig ratio. I'm, again, dealing with tangent of angle A, which is equal to the opposite over the adjacent. So it's literally, when I substitute it, it's going to be this. Opposite 12 over 5. That's it. That's all I need to do. I'm literally taking the opposite over the adjacent. Done. These are going to get a little bit quicker once you get used to it. So let's dive into another one so you can get some more practice. So let's take a look at it. We're going to find sine of Q. So sine of angle Q. That's sine of Q. If I look up here, sine is this one. It is literally opposite over hypotenuse. So opposite over hypotenuse. So now I just need to label my triangle. Step 1, find my 90 degrees and find the opposite side. That will be my hypotenuse. So here's my 90 degrees. Side opposite is 65. So there we go. This is my hypotenuse. I am now going to look at the angle that I'm referring to. What is my angle? It is literally Q. So looking for the angle Q. This is my angle right here. This is what I'm referring to. So looking for the side opposite to it literally is 56. So this is my opposite side. Then the side that is next to or adjacent is going to be that last leg right there. So this is adjacent. And there we go. I have labeled my triangles. I'm concerned about only opposite and the hypotenuse. So there we go. Write my trig ratio. I'm going to construct it. Sine of angle Q is equal to opposite over hypotenuse. So it's going to be sine of Q equals 56 over 65. Now, we do have to simplify, right? They want us to simplify our fractions. So double check your fractions are the most simplified form. If not, simplify it. Use your calculator to help you simplify it. So make a fraction. Your calculator does the simplifying for you. So I'm going to take 56 divided by 65. Press enter. It is the most reduced, so I'm going to keep it. Let's say you had one that was 20 or 12. Let's say we had one that was 12 divided by 36. If we press enter, the most reduced fraction would be 1/3. So always do the most reduced fraction or simplified fraction. Okay, so we had an example where we looked for tan and we looked for sine. Let's go to the next page to see more examples. We haven't done cosine, so we're going to probably do cosine. So here we're on our next page. We are going to be looking for cosine. And then also what IXL is going to do is they're going to require you to find sine, cosine, and tangent. So they're going to ask you to find all three, okay? So we're going to do that. We're going to do an example with cosine, and then we're going to look at an example where we find all trig ratios. I do want to emphasize before we get into the practice that instead of using angle A, sometimes we'll use theta. This is a Greek symbol or a Greek letter that looks like a special zero, but it's really just a Greek symbol. Okay, so if we look at our diagram right here, our angle that we're referring to is theta. Okay, that is going to be the angle that we're looking at. The side that is opposite to the 90 is literally our hypotenuse, so this side is opposite to it. So this is the hypotenuse. Perfect. The side that is not touching or opposite to the reference angle that we're looking at, the angle we're referring to, theta, that is our opposite side. So you can see that is opposite. That was real bad. I'm going to redo that one. There we go. And the side that is next to or adjacent is this one right here. So again, adjacent, if you ever see it, just in your head, think of next to. So what side is next to the angle that we're referring to? Okay, let's take a look at the first example, cosine. So we have cosine of t. So you can see right here, cosine of t. I'm just going to write it right here. Cosine of t is equal to, if we look back up here, is adjacent over hypotenuse. So I always like to do adjacent AJ or ADJ over hypotenuse. Perfect. Okay, so we're good. Now we just need to identify our angle. In our case, it's t. So angle t is right here. This is the angle that we're looking at. So again, this is my angle. This is going to be helpful when I label my triangle. So let's label my triangle. Always look for the hypotenuse, or I always like to look for the hypotenuse first. Look for the 90 degrees, find the side opposite, boom, this one right here, hypotenuse, perfect. Then I need to find the opposite side. Okay, what side is not touching? Well, this side is not touching. It is literally opposite to the angle that we're referring to. So this is opposite. And then the adjacent side is the one next to or touching the angle we're referring to. Boom, adjacent, got it. Okay, this is going to be perfect. Unfortunately, we have one problem. What is that problem? We don't know our hypotenuse. We need to know our hypotenuse to fill out the cosine of t. And unfortunately, we don't. We have adjacent and we have opposite, but we don't have the hypotenuse. That's okay. We know a way to find that third missing side using Pythagorean theorem. So this is where they're going to kind of add an extra step. They're going to tie in Pythagorean theorem into constructing trig ratios so you get more practice with both. Okay, so again, we are going to use Pythagorean theorem not because we were using it for the trig ratio, but to find the missing side hypotenuse right here. So let's put right here is in a side. We'll go down here. So this is where we're going to be finding the hypotenuse. Okay, so I can call this one A and this one B, and I'm looking for C, the hypotenuse. So I have 10 for A and 24 for B. So A squared plus B squared equals C squared. I just said it, but I think it's 10 and 24. So 10 squared plus 24 squared equals C squared. So I substitute A and B. Now I can just use numeric solver to kind of help me quickly find that missing value. So let's do that real quick. Find C. Let's do it. Math, numeric solver. Let's do 10 squared plus 24 squared. I'm looking for my hypotenuse, so I'm going to have this one as x squared. Go down here, do 1, press alpha, enter, and I get 26. That was real quick. So C is 26. That makes sense. If we look right here, hypotenuse should be the longest side. So if this is equal to 26, it is bigger than 10 and 24. So we are good. Now, a little aside, we come back. Our goal is to find cosine of angle T. So cosine of angle T is equal to the adjacent side, 10, over my hypotenuse, 26. This one, let's check if we can reduce it. Remember, they want the most simplified fraction. So let's grab our calculator. Let's see if we can simplify. So go back to the default window, alpha, enter, press enter, 10 divided by 26. It does reduce, so we can reduce it down to 5 over 13. So again, most reduced form of cosine of angle T is equal to 5 over 13. You would put the fraction 5 over 13 in IXL. Okay, that seemed like a lot. Let's take a look at everything that we learned and put it together. Here, we need to find sine, cosine, and tangent of angle F. So our angle that we're referring to is this angle right here. So I'm going to make sure that we emphasize this is our angle. First step we need to do is just label our triangle. We need to label the hypotenuse. Easy. It is the side opposite to the 90, the right angle. So this right here is my hypotenuse. Then I need to label my two sides, adjacent and opposite. Looking at the angle that we're referring to, angle F, the side opposite to it is 8. So this right here is the opposite side. There we go. The last side, the side that's next to it, is the adjacent side. And unfortunately, we do not have the adjacent. It is required for us to do sine, cosine, and tangent. So let's quickly find that using Pythagorean theorem. A squared plus B squared equals C squared. Hypotenuse is always C. I can label this one A, and I'll label this one B. So I'm looking for B. I know what A is. A is 8 squared plus B squared, what I'm looking for. And C, the hypotenuse, is 10 squared. So I substituted my values. Again, I'm just using Pythagorean theorem to find the missing value. Grab my calculator. Quickly do numeric solver to find that for me. I can do it by hand if I wanted to, but I'm just going to do this for convenience. So 8 squared plus x. Oh, clicked on the wrong one. Sorry about that. 8 squared plus x squared. Drop down, put in my c squared, which is 10 squared. Press down, press 1, press alpha, enter. Or again, I'm just putting the value 1 in there as a guess. What I get is this big number, but really if I look at it, round to just 6. So B is 6, leaving us the adjacent side to be 6. There we go. Now I have to just use my labeled triangle and find each part. So now on to doing sine. So again, sine of, what's my angle again? Sine angle F. So I'm going to do angle F. And sine of F, if you don't remember, go back to the top. You can have it, but it is literally the opposite side over the hypotenuse. So looking at opposite side is 8 over my hypotenuse, 10. You can reduce that, so go back to the default window. If you know it by hand or by what you're seeing, that's fine as well. So 8 divided by 10, press enter. We'll reduce down to 4 over 5. So that would be my answer for sine of F. Let's do cosine of F. That is adjacent over hypotenuse. What is my adjacent side? 6. Still, my hypotenuse is 10. I can see if that reduces. I'm going quickly, but you're going to get more practice. This type of question is going to be near the end, so you'll have plenty of practice. So you'll be much quicker with these. So cosine of angle F reduces down to 3/5. Perfect. Tangent of F is equal to, the last one I need to find is tangent of F. That is the opposite side over the hypotenuse, over the adjacent. I almost made a goof. Always double check. Yes, opposite over adjacent. So what is my opposite? It was 8. And my adjacent was 6. So I can reduce this down. 8 over 6, press enter, 4/3. So I would put in this value, and this value when I would be answering the question. This was a lot of information. Trust me, guys, you're going to get better through practice. So if you have any questions, please reach out to me. Otherwise, good luck, guys. The IXL that you need to work on right here is IXL VLY. Okay? You only need to get a max of 80. I have this diagram to kind of help you because you are going to be utilizing Pythagorean theorem to help you find missing sides so you can then construct all these trig ratios. Don't worry, in the next video, we'll talk about this. But otherwise, good luck, guys. If you have any questions, reach out. See you in the next one.